Welcome back, everyone. In this class, we're going to take a look at Python sets and Frozensets, what they are, how to use them, when to use them. We'll compare and contrast. Python sets are used to contain unordered collections of objects. Unlike tuples and lists, sets are unordered and therefore cannot be indexed by numbers. Duplicate values are not permitted within a set, and they support operations related to mathematical set theory. A great application for sets, since they don't permit duplicates, is doing just that, removing duplicate values from a sequence or another Python collection type. We're going to look at examples. So the question sometimes comes up, are sets mutable or not? In doing research for this module, I've seen some controversy as to whether they are or aren't. Mutable means that you can change them once they've been created. I believe they are mutable, and here's my proof. Okay, so look here. I have list 1 with a whole bunch of numbers in there. Then I create a set from a list. Set 1 equals set, and then you see I have list 1. I print set 1. Note, the set will remove any duplicates that we have in list 1. So when you follow the red dot, you will see I now have 1, 2, 3, 4, 5, 6. No duplicates. I can print the ID of set 1 and you see what that number is. I can pop set 1 because sets are mutable, but let's prove that. Let's satisfy ourselves. Now we can print set 1 and you see that the number 1 is gone. I just have 2, 3, 4, 5, and 6 remaining. And then I can ID that particular set and you see that the number is the same. I'm not recreating a new object. I am changing the one that I have. If it was immutable when I created this, then it would give me a different number altogether. The ID would be different, saying that they were two completely different objects. When in doubt, I say go to the source. The set type is mutable. The contents can be changed using methods like add and remove. The source for this statement is the Python Software Foundation. Note, there is a second set type called Frozenset that is immutable, and we're going to go into that just in a short while. Now let's look at the different ways that we could create our sets. So the first one up here on the left-hand side, we can use what's known as the constructor method. Set2 equals set, and then we're actually passing in a list of 4 numbers, 1, 2, 3, 4. And then when we print set2, we see that we get a set of those same 4 numbers. In the second one, my_set, set equals hi there, we're passing in a string. Notice here, it takes away the second E, and it also includes the space. We convert a string to a set. The second way to create a set is using curly brackets, which is also known as the set literal version. And we can mix our types here. So notice I have numbers and a string. So when I do that, set3, I have 5, 6, 7, 8, and HI. A third way to create this, you might remember comprehension from dictionary comprehension and list comprehension. There's also something known as set comprehension. So set4 equals x times 2, 4x, and 2, 4, 6, 8. And you see set4 takes each of those numbers in that list and multiplies them by 2 to create our final set. How do you create an empty set? You see here on the right-hand side, S1 equals set, and then open and close parens. But you can't do it with the literal type. Why? The set literal type, because that's also how one would create an empty dictionary. So when you do that and we type S2, you see it's actually a dictionary. So you have to use the constructor method for the empty set. And as always, if we do the dir method against our set4, we'll see all the various methods and attributes we have at our disposal that we can use with a set object. Now over the next several slides, let's use some of these methods in action with our sets. So set1, 1, 2, 3, 4, 5, set2, 2, 4, 5, 6, 7. We can add an element to a set, set_1.add 7, and we print that out and we get our new set on the right hand side, 1, 2, 3, 4, 5, 7. We can use math operations with sets. This shows the difference, set1 minus set2. This shows intersection, what they have in common, set1 and set_2. The union, combined, set1 pipe, set_2. The symmetric difference, or the XOR, in one or the other but not both, and that's the caret, set_1 caret, set_2, and is set1 a subset of set2? The output's false here, and that's the greater than sign. We will continue to look at methods of the set on this slide, and most specifically, we want to compare and contrast the add method to the update method. So here at the top, left-hand side, set_3 equals hi and hello. So if we do a set_1, update that with set3, and then we print set1, we see that works just fine, right? We get what set1 used to be, which is 1, 2, 3, 4, 5, 7, and it adds now hello and hi. Great, the update worked. Now we do a set_4 equals 22, comma. Then the next thing we do is a set1 dot add set4. And it says, no, you can't do this. This is a type error, unhashable type set. And then we try to do the same, set5 equals 44, 55, 66. Can't do this type error for set. Okay, so we see that. So what's going on here? An item is hashable if it has a hash value that never changes during its lifetime. All Python's immutable built-in types are hashable, for instance, numbers and strings and tuples. And then immutable types are things like lists, dictionaries, and sets. You may only use the add method with hashable types. So now look here, the green button, set_1 add hello. This we can do. Why? Because a string is immutable. We can also do it set1.add 404. This works too. Integers are immutable. Set1.add pizza, comma, with the parentheses around it. This also works because tuples, again, are immutable and hashable. So all these three types will work just fine. But if we wanted to go ahead with set4, with updating that with set4, we can do that by using the update. So set_1.update set4, and we print that out, and you see that it works. So using the update method with mutables, set.update is basically the equivalent of an in-place set union operation, the merging of two sets. Note, the item that is used to update the set, in our case set1, must be an iterable. For instance, this wouldn't work if we tried set1.update set77. An integer is not an iterable, and that would bring back a type error of its own. Int object is not iterable. So let's dig in just a little bit deeper. What do we mean by a hash object? Just to make sure we're clear. An object hash is an integer number representing the value of an object. Hashes are important because sets and dictionaries use them for their lookup tables to quickly find their keys. To enable this to work, hashes must never change during an object's lifetime. For this reason, your hash cannot be mutable, as mutable objects are subject to change. We'll continue our tour here on some of the methods that are available to us when we're using sets. Upper left-hand corner, S1 equals hi, hello, hiya, yo now. I print S1, the output is yo now, hi, hello, hiya, as we would expect. Then I can remove hiya, and I print out S1, and hiya is removed. Then I can use our pop method to remove an element, and you see when I do this against S1, only hi and hello remain. I do it a second time, and only hi remains. Then I create S2 equals 1, 2, 3, 4. I can do an S2.clear. I print S2, and the set is now empty. I could do an S2 equals S1 copy. I print S2, and the output is hello. I then can do an ID of each of these objects, and we see that they are not the same objects. They are different objects. They reference each other. This is known as a shallow copy. On the upper right-hand side, I do S3 equals 1, 2, 3, 4. S4 is 1, 2, 3, 4, 5, 6, 7. I can use our is. I can test for membership or comparison. So S3 is subset of S4. The output there is true because S3 is a subset of S4. I can ask if S4 is a superset of S3, also true. I can ask what's the difference between S4 and S3. The output is 5, 6, 7. I can look at what the intersection is between S3, those things they have in common, and the output's 1, 2, 3, 4. I can do a symmetric difference between S4 against S3. My output is 5, 6, 7. When I print S4, the output doesn't change. Now, I can do a symmetric difference update of S3, and now S4 will change. However, S3 remains the same, 1, 2, 3, 4. I can do a union of S4 and S3, and that'll combine the two, 1, 2, 3, 4, 5, 6, 7. And now we're on to a Frozenset. A Frozenset is an immutable variant of a Python set object. Unlike sets, Frozensets remain the same after creation. Just like sets, the elements are not ordered. It takes a single parameter which must be an iterable. Compared to sets, since it is hashable. A frozen set can be used as dictionary keys and values inside of other sets and Frozensets. Set values are mutable and not hashable, where Frozenset values are immutable and hashable. These next few operations apply to just a regular set, not a frozen set, because they are immutable. We can't update, add, remove, discard, pop, or clear with a frozen set. All right, let's see frozen set examples in action. Upper left-hand corner, we create list 1, 1, 2, 3, 4. We're going to create a frozen set from this list. The syntax is as follows. fset1 equals frozen set, pass it, list 1. And it works down at the bottom. You see that it's 1, 2, 3, 4. We do the same with the tuple, 2, 2, 3, 3, 4, 4, 5, 5. We see the output, frozen set, 33, 44, 22, 55. We're fine. Now, we're going to do the same with the dictionary. Notice we're not telling it, take the key, take the value, right? The two core parts of a dictionary. Let's see what happens. fset3 equals frozen set, dict1. We print it out, and it comes out blue, beach, sharp. What do those represent in our dictionary? Well, those represent keys. So there's intelligence built in enough in Python that it knows exactly what to do. It takes the keys. Now, on the right-hand side, we can try to compare and contrast some of this stuff with our regular set. So we're able to create our set from our dictionary, the same dictionary. When we try to update it, we're able to update. Why is that? Because this isn't a frozen set, this is a regular set. Regular sets are mutable, frozen sets are immutable. Now, if we try to update our frozen set with yellow sun, a new key value pair for a dictionary, we get an attribute error. Frozen set object has no attribute update. When we try to do the same with the add method, same thing, attribute error. Frozen set object has no attribute add. So since a regular set is mutable, you can add and remove dictionary keys at will using a regular set. This defeats the purpose, however, if you want the keys to remain unchanged. Since a frozen set is immutable, you cannot add, remove, update dictionary keys using the frozen set. The keys will remain forever frozen.